Now let's look at what happens when the activities actually get completed, and if the required duration is either longer or shorter than what was expected, what will happen to the completion times of other activities. So the time required to complete an activity can vary, and that would affect, right? If the activity is on the critical path, then that activity getting delayed would mean all the other activities will get delayed and the project completion will get delayed as well. So what happens to the other activities that are non-critical? What happens to the successor activities and the predecessor activities and so on? So let's look at that sensitivity, and for that we have to look at the activities in a network in three groups. One is, our given activity, and what are the activities that come before that given activity. Those are predecessors. Okay, what are the activities that come directly after it on the same path? Okay, so in one path or another, activities are that come after this. Okay, and then there are activities that do not have any path in common, so those are parallel activities. So in our example here, if you look at this, so you see, suppose if E is what we are looking at, predecessor for E or A and C, successor for E or G and H. Okay, they're not immediate predecessors and immediate successors. These are predecessors all the way to the beginning and successors all the way to the end. Now F, D and B are parallel activities for E because they don't share a path in common. Okay. So they don't come in the way of the same path as E is in. Okay. So what happens if the activity time for a given activity is either increases or goes down? So what's in brackets is decrease in an activity time. So if that happens, okay, what will happen to the earliest start time of successor activities, of parallel activities, and predecessor activities? So all the successor activities, because they share a path, okay, if the time increases, then the successor activity earliest start time will all go up, all the way down. If the activity time decreases for the given activity, then the earliest start time will go down for all the successor activities. Parallel activities, they won't affect anything, and the predecessor activities, it won't affect anything at all. The same for finish time. If the time decreases, then obviously the start time will go up, and finish time will go up also for all the successor activities. Okay. If the time decreases, then it will go down, and no change for parallel activities and predecessor activities. Okay. And the opposite will happen for the latest start and finish times. So I mean opposite meaning for between successor and predecessor in the parallel activities. So parallel activities will get affected because when the latest time changes, when time goes up, when the latest time will go backwards, will cascade backwards to all the activities, not just the ones in the same path. So successor activities will increase and decrease, again increase and decrease for parallel activities, but for predecessor activities there won't be any change. Now the slack, okay, the slack will, if the activity time goes up, both the finish time, both the earliest time and the latest time will change by the same amount, and therefore there won't be any change in the parallel activity and in the predecessor activity and successor activity. But parallel activity will change because the earliest time will not change, whereas the latest time will change. So parallel activity slack will increase or decrease depending upon whether the activity time went up or went down.